बिस्मिल्लाहिर्रहमानिर्रहीम रब्बिश्रहली सदरी व यस्सिरली अमरी वाहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली. Assalamu alaikum. Today we will do quantum mechanics, Mark Beck, chapter 1, 1.2.3 matrices. In our discussion of matrices, we will focus on square matrices, that is the matrices that have the same numbers of rows and column, because 99% of the time in quantum mechanics, that's what you deal with. I'll assume that you know how to make a determinant of such a matrix. I'll also assume that you know how to multiply a matrix and a vector or two matrices. However, to be clear on notation, we'll present some expressions which you might not be familiar with that describe these processes. We'll use Mij to denote the elements in the ith row and jth column of matrix M bar. We'll use bold with an over bar to denote a matrix. Recall that the product of a matrix and a column vector yields another column vector. In n dimensions, the components of B, which comes from the operation of B is equal to M bar A, can be written as the inner product of the rows of M bar with A. Bi is equal to sum j is equal to 1 to n Mij Aj. This is simple matrix multiplication. It is written in compressed form. Bi is equal to j is equal to 1 to 3 Mij Aj. Suppose n is equal to 3 and we have a 3 by 3 matrix. Then by multiplying this matrix with a vector gives another vector. The element B1 is equal to M11 A1 plus M12 A2 plus M13 A3. The element B2 is equal to M21 A1 plus M22 A2 plus M23 A3. Similarly, element B3 is equal to M31 times A1 plus M32 by A2 plus M33 by A3. We are multiplying the rows of the matrix with the column vector. In index notation, if the index is repeated twice, that means it is being summed over. This is known as Einstein summation convention. He realized that if the index is being repeated twice, that means it is being summed over. In our case, the index j is being repeated and is being summed over. Since knowing the component determines the vector, equation 1.41 expresses the multiplication of a matrix and a column vector. Similarly, we can express the elements of the matrix product M bar is equal to A bar B bar in terms of the inner product of the ith row of the first matrix with the jth column of the second. Mij is equal to sum from k is equal to 1 to n Aik Bkj. This is simple matrix multiplication written in the index form. Mij is equal to sum from k is equal to 1 to 3 Aik Bkj. Since n is equal to 3, these are all 3 by 3 matrices. Since k is being repeated twice, this means that it is being summed over. Einstein got tired of writing the summation sign over and over again. Then he came to the conclusion if the two indices are being repeated, it means that it is being summed over. This is known as Einstein summation convention. Element M11 is found by the dot product of the first row with A with first column of B. Hence, M11 is equal to A11 B11 plus A12 B21 plus A13 B31. In case of M11, I is equal to 1 and J is equal to 1 and K is being summed over from K is equal to 1 to K is equal to 3. Similarly, element M12 is the dot product of the first row of A with second column of B. In this case, I is equal to 1, J is equal to 2 and K is being summed over. If we know the elements of A and we know the elements of B, we can find the elements of M. If you carry out the matrix multiplication on your own, you will realize that it is exactly the same thing as the index notation. You are probably already aware, and in problems you will confirm that in general A bar B bar is not equal to B bar A bar. The order in which we multiply matrices matters. Matrix multiplication is not commutative. More typically, we'll say that matrices don't always commute. This has important implication in quantum mechanics as we'll discuss later. Allah bless us all. Thank you for watching. Allah Hafiz.